Hey everybody, Matt Morgan here. In this lesson, we're going to go over some examples of drawing Lewis structures. We will go through the steps of drawing the Lewis structures for the following atoms, ions, and molecules. So Lewis structures are simple models that show the arrangement of electrons and the types of bonds that exist in a particular molecule or ion or even an atom. The Lewis structures for single atoms, pretty straightforward. You start with the atomic symbol, and then you draw dots to represent the number of valence electrons. Now, valence electrons are electrons that are available for bonding. They're not taken up in a closed shell. The main group atoms have a number of valence electrons equal to the group number. So the first example that we'll do, the Lewis structure for the oxygen atom. So how many valence electrons does that have? It's in group 6A, so oxygen has 6 valence electrons. Notice that it has 8 total electrons, but only 6 available for bonding. Those first 2 electrons are closed off in the 1s orbital. The Lewis structure for the oxygen atom is the symbol and 6 dots. That's it. I think the most challenging part is to not make this more difficult than it has to be. So here's a question. Can you draw the Lewis structure like this or like this? And the answer is yes. The important part is that you use the correct atomic symbol and have the correct number of valence electrons. Let's do the phosphide anion. Phosphorus atom is in group 5, but it also has a -3 charge. There's phosphorus. Now the charge tells us we have a phosphorus atom and 3 extra electrons. So what we'll do, we've got the 5 valence electrons, add 3, and we have a total of 8 electrons. And that's why phosphorus makes -3 ions, because it then has an octet. So the Lewis structure for atoms and single atom ions, pretty straightforward. The structures for multi-atom species, whether they're molecules or polyatomic ions, is a little more complex. So the textbook, and also I did another video on Lewis structures, discusses a specific procedure. I'll go over that quickly, and then we'll use that procedure to draw the rest of the molecules in this example. So big picture, what you want to do, find homes for all the valence electrons, whether in bonds or making octets as lone pairs, and make sure you give octets to all the atoms that need them. So here is a short version of those steps. Step 1, count up all the valence electrons for every atom in the molecule. If it's a polyatomic ion, add an electron for every negative charge, subtract an electron for every positive charge. Draw the structure and count 2 electrons for each bond. Next, make octets around the outer atoms, and then with the remaining electrons, make octets around the central atom. If you run out of electrons, make double or triple bonds. All right, let's do the Lewis structure for arsenic trichloride. The number of valence electrons is 26. Now, how do we get that? Arsenic is in group 5, chlorine is in group 7. So 5 for the arsenic, 3 chlorine atoms gives us a total of 26 valence electrons. The initial structure, we'll put the arsenic in the center, surround it with the 3 chlorines. Each bond requires 2 electrons. So we've used so far 6 electrons. So we need to find homes for the other 20 electrons and make sure all the atoms that need octets have 8 electrons. We'll place electrons around the outer atoms, in this case the chlorines, first. So how many electrons have we used? So here's a shortcut for quickly counting those up. If you have a single bond plus a completed octet, that's 8 electrons. So in this molecule, we have 3 of those. 3 times 8, 24. So we've used 24 electrons so far. We have 26 total. We've used 24. Pretty easy. The final 2 electrons go on that arsenic. Are we finished? Well, let's look. We've used 26 electrons. Every atom that needs an octet has one. So we are done. Okay, let's look at the next one. So this is trichloromethane. You don't have to remember that. Number of valence electrons is, we've got a carbon, a hydrogen, 3 chlorines, 4 for the carbon, 1 for the hydrogen, 7 electrons for each chlorine. That gives us a total of 26. Initial structure. We've used 8 electrons so far because every bond is 2 electrons. We need to find homes for the other 18 electrons. We need to give octets for every atom that needs one. So we'll place electrons around the outer atoms. In this case, it's just going to be the chlorines. We'll talk about hydrogen in just a minute. Okay, hydrogen doesn't need an octet because its noble gas is, nearest noble gas is helium. So there are many atoms that violate the octet rule. In fact, I like to call it the octet suggestion. So we have used our 26 valence electrons. For every carbon and chlorine, that's 8. 3 times 8 is 24, plus the 2 for bonding to the hydrogen is 26. Every atom that needs an octet has one, so we are finished. Okay, final example. How many valence electrons? 1 for the hydrogen, 4 for the carbon, 5 for the nitrogen, gives me 10. Our initial structure, we'll put the carbon in the middle. When in doubt, put the least electronegative element, in this case carbon, in the middle. And a lot of times they will tell you which atom to put in the middle. We've used 4 electrons so far. We've got 6 more. So the rules say we'll put the other 6 around the outer atom, which is nitrogen. We've placed our 10 electrons. Are we finished? Hydrogen and nitrogen are happy, but carbon is not. Carbon only has 4 electrons and it wants 8. So how do we get more electrons? We can't just add because we've used all our valence electrons. It says we make multiple bonds when we run out of electrons. So we'll take one of nitrogen's lone pairs and make a double bond with carbon. Does carbon have an octet yet? No, but it's closer. It has 6 electrons now. Nitrogen still has 8. Let's make one more bond between carbon and nitrogen. We'll take one of nitrogen's lone pairs, making a triple bond between the carbon and nitrogen. So we've used 10 valence electrons. Carbon and nitrogen both have octets. Hydrogen doesn't have an octet, but it doesn't need one. There is our Lewis structure. So I hope you found these examples informative and worthwhile. Be sure to practice drawing Lewis structures on your own. And of course, contact me if you have questions. There's my email. We have office hours Tuesday and Thursday mornings, 9 to 10 a.m. You can also make appointments if those times don't work for you.